All right. So I'm just going to finish what I was doing at the end of class. So I said that ionic compounds form from plus and minus charged ions. And they form this continuous array of plus and negative charges. But the thing I would like to focus on here for a minute is that ionic compounds are neutral, which means that they have the same number of positive and negative charges. That means the charges have to cancel, or in other words, sum to zero. So if we take the example of NaCl and MgCl2, NaCl, this is one formula unit. Notice I do not say molecule because it is not a molecule, okay? Because it's a continuous array of ions. One formula unit has one sodium ion and one chloride ion. How do I know that? It's because there are no subscripts. So when there's no subscripts, it's assumed to be one of each. So I would say that there you are. You have a +1 and a -1. +1 from the sodium, -1, they sum to 0. And that's what you get with a ionic compound. And by the way, you could, you might say, well, why can't I write Na2Cl2? Well, that's just not the simplest formula. So you would always reduce it to the simplest formula. For MgCl2, you have in one formula unit, which is MgCl2, you have one Mg2 plus and 2 Cl minus in one formula unit of MgCl2. Okay, this provides a charge of +2. This is -2 because you have two -1 charges, and that again sums to 0. And MgCl2 is the correct formula unit express means where you write the formula unit. Notice you have to have two Cl's to cancel the charge of the single +2 ion. So the charges always have to cancel. But please remember that these are not molecules. And the way to think about that is when you have a molecule, you have actual clusters of atoms that are always together in a sample. In a sample of NaCl, you simply have, this is Cl, this is Na, Cl minus, Na plus, and it's just a continuous array. Here you have some other compounds, CaF2, presumably the blue ones are the fluorines, but it just goes on continuously. There isn't a clump of CaF2 and then another clump. It doesn't exist that way. Again, zinc sulfide, these are all ionic compounds. There are no molecules. So what would it look like if there were molecules? Well, here's a great example. Here's the CO2, another CO2. These are clustered together with spaces in between like this and this. We'll learn what those dotted lines are and what Chem 104. But here, these are individual clusters of atoms. And what do we call them? We call them molecules. So it's very different looking compounds. Okay. So the other thing I talked about in class after I shut off the recording was one other thing was naming ionic compounds. And the way you name an ionic compound is you have the name of the cation first. That's the positively charged ion, followed by the name. You don't put a comma, you just have a space, I guess. And then you put the name of the anion, which is the negatively charged ion. And the convenient thing is that the name of the cation is the same as the name of the element. These are generally metals, with some exceptions we'll learn about later. So, for example, sodium is the name of the metal. Sodium ion is the name of the ion. Magnesium. Okay. It's a little different with anion names. If you have, for example, chlorine, you shorten that to chlor, and then you add the "ide" ending. So chlorine becomes chloride. That's Cl minus. So Cl is chlorine, Cl minus is chloride. Oxygen becomes oxide, right? So you cut it off there and you add the "ide" ending. So MgCl2, again, is simply magnesium chloride. Sodium sulfide here. So the name of the cation is sodium. You take sulfur, you take off the and you put an "ide" ending there. Okay, notice it doesn't tell you in the name anything about the number of each. Doesn't say anywhere in the name that there's 2 sodiums. So why are there no numbers in the names? And the answer to that is because there's no choice of what the numbers might be. There is only one correct combination of ions that gives you the simplest formula. So the Y is because there is only one correct combination of ions to give the formula unit. And of course, it's assumed that you know how to do it right, but it's not going to tell you anything about how many sodiums. So what you have to learn how to do. So you must learn how to go from a name of an ionic compound to a formula. CPD, as you see, that's my abbreviation for compound. Okay, so for example, if you have calcium oxide, okay, what's the formula here? Is it going to be CaO, Ca2O, CaO2, something like that? Only one is correct. So how do you figure out which is correct? Okay. And it starts with looking at what the individual ions are and what the ion charges are. So start by looking at calcium and locate it on the periodic table. And you will see it's in the second column. That's group 2 or 2A, depending on what numbering system you use. And for all elements in group 2, it would lose 2 electrons. So calcium loses 2 electrons to attain the same number of electrons as the previous noble gas. Okay. And if you look at the periodic table, calcium, it's over here. You know, here's beryllium, magnesium, lithium, sodium, potassium. Okay, that's this side of the periodic table is 1A, 2A. On the other side of the periodic table, I don't believe I'm drawing this, but what the heck? Helium, this is 8A or 18, depending on the numbering system. We have Ne and Ar. Okay, so here we have calcium. So when calcium loses 2, so here it would lose 1 electron, become like K, loses the second electron, it becomes like argon. So calcium has 20 electrons, argon has 18 electrons. So when it loses 2 electrons, it becomes like argon, and it picks up a +2 charge because it loses 2 electrons. Okay. You could also see that it's in group 2. And then for these simple group A metals, the charge on the ion is the same as the group number. So +2 for calcium ion. Okay, so Ca is +2. What about oxygen? Well, oxygen is over here on the periodic table. Okay, it's in group 6A, 16. It has to gain 2 electrons. Right, this would be fluorine here. So it would gain 1. So it would go from 8 electrons to 9 electrons, and then here to 10 electrons. I can't, it just doesn't manage to draw it, but neon is 10 electrons. There we go. So oxygen gains 2 electrons, becomes O2 minus. So if we have a Ca +2 and an O2 minus, you could see that the charges are balanced, and they would cancel. +2 minus 2 is 0. So it would just be CaO. So this is the correct formula right here. This one, CaO, is correct. Okay. And you wouldn't write it as Ca2O2, right? That's not reduced. You need to reduce it. Okay, I'll do another example. Calcium bromide. Okay, so this is Ca2 plus. If we look on the periodic table, we see that bromide is in group 7A or group 17. It's right next to 8A, so it'd have to gain 1 electron to get the same number of electrons as the next noble gas. Okay, so it just gains the 1 electron. So bromine would be Br minus. Okay, so now you have calcium +2, bromide -1. Clearly you need to have 2 of these, because that would give you -2, which would cancel. So you would have CaBr2. Okay, another thing is that there are, you do not include charges. No charges in the final formula. Okay. And I want to do one more before I let you go on and do the first 5. And that is, I want to do a transition element example, copper to chloride. Okay, I think we talked about chloride, right? Well, chloride is right there, and the same chloride is Cl minus. It's in group 7A. It only needs 1 electron to be like the next noble gas. And the next noble gas would be argon. 17 electrons in chloride, 18 here, so you just needs 1, so it's -1. Copper 2, the fact that it has a 2 here tells you the charge on that ion is +2. So we have a Cu +2 and a Cl minus. You could see that you're going to have 2 of these to balance 1 of these. And then that gives you a +2 and a -2, which sums to 0. And you would write the compound as CuCl2. You don't have any charges in here that you put, and that 2 becomes a subscript. The Cu doesn't have one. When it has no subscript, it's assumed to be 1. Okay, but it's never, the 1 is never written. So that's CuCl2. So I'd like you to do this, activity 3, 1 to 5. If you don't finish it in class, I'm going to come around. If you don't finish it in class, finish it at home.